welcome to Excel at Science TV. Today we're going to take a quick introductory look at freefall and vertical projectile motion. First thing to understand is what is freefall. Good news, it's not rocket science, but I guess if there was no freefall and gravity then we wouldn't need rockets. The biggest clue to understanding freefall is right there in the name. It's all about an object falling freely with no other forces acting on it other than gravity. And interestingly, we use the same term for a ball on its upward trajectory as well as when it's coming down. From the instant that it leaves my hand, gravity is the only force acting, causing it to slow down and be brought back down to Earth. But what better way to understand freefall than to free fall? And that is why we are here.
Hey Colin, how you doing?
Good yourself, man?
Good.
Ernest?
Hey Colin, how's it going?
Good, man. Good. So gents, what's the plan?
Well, we've been checking out the various options that we have here to experience some free fall for ourselves.
That's great, yeah.
And great options they are. We've got bungee jumping, base jumping, and a power swing.
But, I think the best option for us is going to be the SCAD free fall.
Yeah, okay. That sounds awesome. Very terrifying. We're going to check it out. Let's do that. Excellent. Guys, so what exactly are we going to do here?
Nothing too crazy. All they do is they haul us up about 20 stories in that little cage over there.
Yeah.
And then once we're at the top, suspend us on a piece of rope and then drop us.
Whew. Okay, sounds fun.
That's when SCAD comes in.
Right.
That's the suspended catch air device. In other words, that big net that's going to catch us.
Good. Let's do it, gents.
So how high is the free fall?
There's only 70 meters, my man, but I'm not quite sure how long you're just gonna fall, but the net will be lifted up, my man.
Okay, so the net's not on the ground anymore.
Not at all.
Okay, that's really. So, I mean, guys, is there any way that we can actually work out how far we're going to drop?
Sure, no problem, Colin. We just need to get some facts straight with regard to projectile motion. That is, there are 4 possible scenarios. We are just going to be looking at the first scenario now, where an object is simply dropped.
And because it's simply dropped, it means our initial velocity is 0, which makes our entire calculation much easier.
So, guys, how are you feeling about this drop right now?
Not as calm as I was earlier.
It's easy. Yeah, I suppose the only good side is that you're hanging from a string, so you don't have much of an option. You just get cut.
Are you ready? I'm ready. Alright. 3, 2, 1, go! That is amazing! That's terrifying.
At the instant the object is released, its initial velocity is 0 and it starts to free fall. So there I am accelerating at g, which is 9.8 meters per second squared, which basically means that my speed is gaining 9.8 meters per second every second. That's like 0 to 100 k's an hour in less than 3 seconds. In the words of Jeremy Clarkson, that's faster than a Ferrari Enzo. Not too shabby.
Okay, well, let's see how brave the other guys are now. Okay, so now we need the time. Are you guys ready? Back on terra firma.
Yeah.
Welcome back.
Feels so good to be back.
3, 2, 1. How do you feel?
Adrenaline pumping right now. That's it.
Ernest, my man, we did it.
So guys, how was that?
Oh, wow. Let's just say, doing those freefall problems will never be the same
I
again.
know exactly what you mean.
It was quite intense. But actually, how long did we take?
Well, we got a time for each of you, averaging them out, about 2.04 seconds in the air.
Is that
No
all?
strings attached. I know, it's unbelievable, because it felt like forever. You're falling, it's like, when is this net going to arrive? Exactly. It's crazy. But eventually, yeah. So 2.04 seconds, if that's our time, then how far is the freefall?
Well, we can use equations of motion to calculate that. And also, that Refo thing you have, Colin.
Ah, Refwa. Refwa. Now that is a little secret we'll have to tell you about another day.
So, we can put together a list of values of things that we know and the things that we're trying to find. We started off as knowing that the initial velocity is,
Like I said earlier, 0. So easy.
and we know that the acceleration is 9.8 meters per second squared. So, let's take downwards as positive for this case. Colin, what did you say the time was?
Time was 2.04 seconds.
Good. And we're trying to find the height, which is delta y. So taking a look at the list of values and our equations, we can see that the equation we're interested in is delta y is equal to vi delta t plus a half times a times delta t squared. And since our initial velocity is
0.
it simply works out to a half at squared. And a half of 9.8 is 4.9. So, in essence, the total distance covered is going to be 4.9 times the time taken squared.
That is so cool, because actually, how many times have you stood at the edge of a cliff and you drop a little rock off or something and you're thinking, how far is it down? So you just take the time, square it, multiply it by 5, and that roughly gives you your height. Very cool. So Verlin, the Verlinator, give us the actual answer.
Let's have a look. Okay. It works out to be 20.39 meters.
20.39 meters, flying through the air like a bird. And it's about, it's about 7 stories. Have you ever jumped out of a 7-story window?
No,
Okay, no.
not even one.
Well, there you go. You don't have to throw yourself off into the ether to work these things out, but whether you're doing it in the air or on paper, it's pretty awesome.
In the next episode, we're going to look at some more complicated scenarios of projectile motion where things get really interesting.
Till then, try not to leap off any height without a scad beneath you. And keep practicing those equations because, as Verlin so eloquently put it in his rapid descent, science rocks!